Lesson 15, part 2. Probably the single most important problem that we're going to do all year. A plane flies 34 kilometers north, 30 degrees west, and after a brief stopover, flies 58 kilometers north, 40 degrees east. Determine the plane's displacements. Draw a very careful diagram for the questions like this one. Make sure you carefully draw the angles to properly show the two vectors being added head to tail or tip to tail. Okay, so we're just going to do a sketch of this, just so you get an idea of what the answer should be. And as it says, do it carefully. So first of all, we have 34 kilometers north, 30 degrees west. Now I'm just going to draw these separately. So I'm going to draw that one. North starts at north and goes 30 degrees towards the west. So it looks like that. There's your 30 degrees. There's your 34 kilometers. After a brief stopover, flies 58 kilometers north, 40 degrees east. So north here, east here, starts at the north, goes 40 degrees towards the east, so it's a little steeper, and is a little longer, 58 kilometers. So when we combine those in a sketch, we're going to get something like this. Here's your 34, and then you place them tip to tail. So here's your 58, 34, 58, and here is your resultant vector, right there. That's the resultant vector right there, and the resultant angle you're looking for is actually going to be this angle in here. You could do it as this little angle in here, but it's probably easier just to look at it as this angle in here is the resultant angle. This red vector is the resultant vector. So that's what your sketch is going to look like. And the first thing you notice is it's not a right angle triangle. So we can't use SOHCAHTOA with this specific triangle right here. What we need to do is what we did in the previous problem. We need to separate each vector into components. And then we're going to make a new triangle. So we're going to solve this problem, and then at the end, we're going to write down the procedure for solving these two-dimensional vector problems, which are going to come back again and again in Physics 20 and again in Physics 30. All right, so step one is to separate each vector into components. Let's actually write it down. Step one, separate each vector into X and Y components. Okay, here we go. We're going to be very meticulous and slow about this, just so you're really clear. So the first vector we said was, I'm going to draw it again, 30 degrees north, 30 degrees west. And so it has a northerly component, or an or Y component, and a westerly component, which we call X. And we know that this was 34 kilometers. So sine and cosine. And as soon as you've done this enough, you'll get the hang of it, and you'll realize you're always using sine and cosine to separate the components, and most of the time using tangent to get the angle. So sine and cosine to find the X and Y values, and be careful here because of the orientation, because of where the angle is. We're going to use sine to find X. So to find the X component is going to be the sine of 30 degrees equals the opposite, which is X, over the hypotenuse, which is 34. And that gives you X equals 17. Now, because it's going in a westerly direction, I'm going to stick a negative in there. We're going to say the west and south are negative and north and east are positive. All right, let's go to the Y component. The y component is going to be the cosine of 30 degrees equals y over 34. And that's going to give you, and it's positive because it's going up, and that gives you 29 kilometers. So that's vector number one in two components. I'm just going to put a box around those so they're easy for me to see. Now I'm going to do vector number two with components. And vector number two was north 40 degrees in here, and it was 58 kilometers. And so this vector has a northerly component and it has an easterly component, 40 degrees. Okay, so same procedure. My x component is going to be, here's my x, here's my y. My x is going to be sine of 40 degrees equals x over 58, giving me an x value of 37. And since it's east, we're going to say positive 37. My y value is going to be the cosine of 40 degrees equals y over 58, give me a y value of 44. And since it's east, it's also going to be positive. Okay, let's put a box around those. Now, so I've separated it, I've done step one, separated it into components. Step two is to add those components, add the x's and add the y's. And just to go back to your original, you can see, let's look at this diagram right here, this one here. And let's look at it and see how adding the x's and the y's actually makes the resultant. Different color. Right, so here's the x components of this vector. Here's the x components of this vector. One's going this way, one's going this way. And if you look at it carefully, you can see that if you add those together, they actually make the x components of the red vector. Right? And then look at the y. This is the y components of this vector. This is the y components of this vector. And you can clearly see that together, when you add them, they make the y components of the red vector. This is why we're adding the components. So step two, add the components separately. Step two, add the x and y components separately. So x, my x components, so I circle them, are going to be negative 17, positive 37. So negative 17 plus positive 37 gives me positive 20. And my y components are going to be 29 plus 44, which gives me 73. And remember, these are all in kilometers. I don't really need to put kilometers now, but we'll need to put it at the end. And just so we're really clear on the direction, this is 20 kilometers east. This is 73 kilometers, kilometers north. So my final direction is going to be in the northeasterly direction. Okay, on to step three. Step three is going to be to make a right triangle with the new x and y components. So whatever answers we got from step two, we're now going to make a new right triangle, and this is why you only need SOHCAHTOA. You don't need the cosine law or the sine law necessarily. You can use those. But SOHCAHTOA is going to work for everything that we do because we're going to turn it into a right triangle. So you back into this, 20 east, 73 north. So make a new right angle triangle. So what it's going to look like, 20 to the east, 73 to the north. quite a bit bigger. There's my right angle. There's my resultant. And there's my resultant angle. Oops, sorry, that should be R. R for resultant, and there's my resultant angle. Make a new right-angle triangle with the new x and y components, and we'll just put and solve. Solve the triangle, we should know means solve for the resultant vector, its length, and the resultant angle. Okay, Pythagorean theorem, inverse tangent. So R equals the square root of 73 squared plus 20 squared, and that turns out to be 76. And theta equals the inverse tangent of 73, the opposite, divided by adjacent, and that turns out to be 75 degrees, so it's quite a steep line. And then the last step is to just write your answer. I don't think we need to, well, we can write it step 4 is your answer. And your answer in this case is 76 kilometers, comma, bracket, right? And this is 75 degrees north of east, but we prefer, we're going to start at the east here, and then we're going to go 75 degrees towards north. So east, 75 degrees north. That's one acceptable answer. The other acceptable answers would be 75 degrees north of east, or north 15 degrees east. 75 and 15 make 90, or 15 degrees east of north. And there it is, a two-dimensional vector problem. If you can solve that, the rest of this course is going to be a breeze for you.